I'm going to show you our entire 3D motion capture lab. This is our entire black room, and we installed 8 cameras in this room. The room size is 20 feet by 30 feet, and you can see the VHA mounted cameras in this way. This is our portable camera. You can see the IR LEDs are glowing there, so that means camera is on. So, and this is a very light weight and easy to use the camera. You can see there is no additional or no many connections are there. There are simple 2 cables to connect with each other. You don't need to apply you don't need to give an external power supply to each camera. This is our motion capture system. You can see that we mounted on a wall. We mounted it fixedly. We have mounted on 8 different positions. So this is our entire 3D motion capture analysis lab, and you can see surface should be black, but right now we used some mats and all. This is our calibration frame. This is the L calibration frame. Using this frame, we have to calibrate the all camera before doing the analysis every time. So now I will show how to do the calibration. This is our Max Pro Innovision software. Okay, I'll show you. Just let me click. Okay, before going to use it, we have to select the camera. Then we'll select the camera this way. It will detect all 8 cameras. Then it will show you the pop-up that all cameras are detecting. So after that, you have to click on next. Then the system will ask you which one is the master camera. Then we have to select that camera. One is our master camera. You can see it. This is our camera. One is our master camera. So after that, we have to finish it. Then we have to go into the calibration system. Okay, then we have to go for the calibration system. You will see the bottom line viewer. Click on the viewer tab. You can see we kept L frame in the center of all 8 cameras. All 8 cameras focusing to the center of L frame. So that will help us to for the calibration. We have to do this activity. You can see that one person will wand the T-shaped wand will move around the L frame. It should be like this way. We have to move it. No. So we have to ask our person to wand that frame, to wand that T-shape in front of L frame. This is the calibration procedure. We have to do it properly to get the matrix. Then we have to press click on the calibrate, and we have to inform that person to move that wand around the L frame, and you can see that it will, and we have to cover the maximum area so that we can get many coordinates and segments to get the more precise result. The metric of calibration should be less than 1, or 1 is the okay, but we have to try to keep it less than 1. We can see the preview of calibration. Okay. Yeah, this is we have done the calibration. Now software will show the calibration result, and we can see the calibration merit value is 0.87 or 1.37. okay, thanks. This is the way of calibration. Now we'll go for the measurement. Okay, this is our calibration values. We have to accept the values. Then the camera will show you the date and time of calibrated. You can see that 17/5/2023, and this is our time. We have done the calibration on this time. Now we'll go on the record motion, and I'll inform the person of my patient, or you can say the person to wear the cameras, to wear the markers on body. Just 1 second. After successful calibration, we have to remove that L frame from the cameras, and we have to keep aside. Using double-sided tape, we have to stick that on body, but right now we are just sticking this onto the cloth. This is the reflective markers so it will detect these markers in the camera, and that will help us to track the to create 3D in software. You can see that a person is mounting that sensors on his body, and we are using that double-sided tape to stick it on the. This is our double-sided tape, and it is easily available in the market, so we have to just stick it on our body. Now my person is ready to walk in front of camera. All markers are mounted on his body, and now we have to click on the record the motion, and my person will start for the walking, and it will detect all the mount. I'll show you how to do that. Now click on the record, and now you start walk. Completely start. My person is started walking in camera. You can see he's walking in this direction. Okay. चलो ना यार. You can see these are the segments. You can see these are the segments we are getting in the software, and these are the raw data. So we have to frame that data in 3D using the markers. We have to make it stick. I'll show you how to. Okay. So we have to click on the segment, then click on the control, lift it and drag it. Click another segment, lift it and to drag it. Click 100% field segment and lift it and drag it. We have to do that, and these are our 6 markers. You can say this is 7 markers, and this is the 8 markers. Total 8 markers. We can see the 8 markers, and this is we given that segment we are given the marker names, so we can edit the marker names also. Like this is the shoulder. We can put the marker 1 will be a shoulder, marker 2 will be left hand. Okay, and we can do again marker 3 will be left knee. Okay, we can do that, and even we can change the color also. So can for any other we can give the green color. It will show you the green. You can see the marker color also changed, and its name also is coming there. So this way we have to do that. We have to change the color. We can change the name. We can do the color. We can change the color and rename also. Okay, I will do that, and I'll make a stick. Okay, now you can see that we have to connect all 8 coordinates with each other using. We have to click on the shift key, and then we have to select another coordinate. Then it will make you one this way stick. So this is the stick. You can see that overview, multi views. You can check the multi views of this one, and now you can click on the play. You can see that this is the person who is walking. Is taking back 1 step, second, third. He is walking. At the same time, this is a 3D file. You can do position versus time, velocity versus time, acceleration versus times, residual versus times. You can study the many parameters using this 3D file. So this will help you too for your biomechanics studies and course studies. And this is the great. Thank you so much.